Okay, now you can see here a very beautiful representation of your population linear regression model. So if you just, for example, you know the population comprise several values in your data, and we're not going to plot each and everything. Just to make you clear the concept, they have just picked up the sufficient value from your data, and they have just plot over here in the form of a scattered plot, you can see. And then they have assigned the best fit line, a line that can on which the maximum points should lie, and those points which are not lying, it should be very close to this line, and such line is taken to be the line of the best fit. So over here they have just assigned a best fit line. Okay, now this point, as they have just said, this is representing the actual value or the observed value. Okay, there are several terminologies used for just one thing. No need to get confused in that. So this is said to be the observed value, the value of your dependent variable that is present in your set of data. Okay, that is taken as the observed value. You know that. So as I have just briefly discussed all that thing in my previous videos. If you just review that thing, it is going to be further clear to you. Okay, and all the points which are going to lie on the subjective line of the best fit, they are taken as the estimated or predicted value of the y with respect to the corresponding value of your x. Like if I say that this is a certain x value with respect to which you were having your this value of y, and this was the observed value that you extracted from your data while compiling it or while doing the survey, all that. As far as the estimated value is concerned, with the same value of your x, this x is putting its projection on this best fit line right over here. So this point is representing the predicted value of your y. This is said to be the predicted value of your y. Okay, like over here. So you can see, like if this point is this is representing your value 10, this is representing your value 5. Okay, so this 5 is your estimated value that you have obtained with respect to the best fit line on the basis of the same independent variable x, and the observed data or the actual value that you obtain from the set of data is representing the y value 10 corresponding to the same x independent variable. Okay, so this is the actual value and this is the predicted value. Okay, or you can say the observed value too. So the difference between these two answers is called the error. Okay, presently the error is 5 here. Okay, 10 minus 5 give you 5. Okay, this is your y, this is your y dash. Okay, and it's giving you a 5. So 5 is over here, is your error. It's your error, epsilon. Okay, so in other words, if you just try to understand it over here, so you can see that this is the point, and the distance between the actual point and the predicted point or estimated point, this distance is the random error. The same thing. Okay, random error, there are several terminologies for the random error. You can call it random error, you can call it residual error, you can call it random residual derivative. So there are several terminologies related to this epsilon. So as I've told you in the beginning, that this yi is actually the observed value, and observed value is so obtained by adding your epsilon or error value with your predicted value. Okay, like that. This is your I. Okay, so this is your yi. So this observed value can be obtained by adding the error value in the predicted answer. Okay, that's it. And as far as this line is concerned, over here they have just written the equation of this line. If in the simple words, it is actually y dash, it is equals to mx plus c. Okay, where c is what? C is the y-intercept, means the point where this line is cutting this y-axis is called the y-intercept. can see that this point is your C. Okay, and beta 1 is representing this m over here, and m is the slope. And I've just told you in the very first video of mine, the correlation part 1, over there I discussed how to calculate the slope of any line. Okay, we can repeat it whenever there is a requirement. So beta 1 is the slope of this line, and beta naught is the y-intercept of this line. So this is the line of the best fit that we obtain with the help of the scattered plot that we have just plotted with the help of the values that we obtain through the population survey, the entire population survey. This is a quite time-consuming thing. We do not have that much time, so we need a shortcut method in order to obtain the corresponding value of your beta naught and your beta 1. So for that purpose, we just take out the sample out of this population data, and we call that data as the sample data. And then we plot those sample data values over here on the graph. We obtain the line of the best fit, and in that respect we just obtain the corresponding y-intercept of that sample best fit line, and we obtain the slope value of the same best fit sample line. And with the help of those values, we are going to estimate the best possible answer of our beta naught and your beta 1. Okay, so no need to get confused in this mu. This is the Greek letter mu, and actually they have used this mu yx. This mu yx is representing the estimated value of your population. Okay, so no need to get confused, it is just a representation. All right, so that's it.